Welcome back to the Beginner Game Programming Series. I'm Chili, and this is Lesson 17. And check it out, my desktop is clean and clear. I liked it better when it was messy. Let's do the lesson. Today we're talking about strings, and this is going to be some epic shite, bro. So you better strap yourself in. Without further ado, let's get this mother rolling. I want you to open up your integrated development environment. We're going to start a new project, so fire up your IDE and click on New Project. And want to make sure you're at Win32, not CLR. CLR bad. Win32 good. You want a console application here, and you can click on Browse and select your folder for your new project. And last but not least, we have to give our project a name. You can give it some kind of obscene name if you want, because you're that kind of sicko, aren't you? I'm gonna name mine Strings because that's what we're talking about today. And it seems rather apt. Now I want you to click on Application Settings, and we want to customize our project. We do not want a precompiled header. We never want a precompiled header. Precompiled headers are a bag of dicks. We want an empty project. Finish that. And Viola, you have a new project. Now, because it's empty, that means it has nothing in it. Derp. So we have to add shit. Let's add a new item. We want to add a CPP file. The name of our CPP file will be called main. Main.cpp. We'll add that mother. And let's get on with it. Let's make a program. We're going to make the world's shortest C program. Void main. Good night. That's the program. That's all there is to it. So you can build it. Builds fine. You can run it. And what the hell? Let's try that again. Yeah. If you try to run it, you will notice that the window disappears almost immediately after it starts. That's because when our program exits, which is to say immediately, the window will automatically close. That's how they're made to work. Console windows. But that's a problem because if we want to examine the output, we don't really have an opportunity for that. So what's the solution, Chili? I want you guys to right click on the toolbar and go customize. Then you're going to go commands up here. Click on toolbar again. Slide down to standard and go add command. Then you want to go to the debug category, slide that mother down, and select start without debugging. Click OK. Don't click close yet. Now we have start debugging here. Let's move it down until it's beside of our normal start command. And now if we noticed at our normal little triangle icon here, right beside it is a new one called Start Without Debugging. Good times. And if we click it, we will notice that now the program sticks around for a while. The reason for that is when you use Start Without Debugging, the IDE will insert a script after your program that will prevent the console window from closing automatically until you press a button. That's the good news for it. The bad news is when you do start without debugging, you can't use the debugger, so you can't have breakpoints, and you can't inspect the variables as the program is running. But, well, I mean, if you're going to be having breakpoints, then you don't have to worry about your program closing too fast anyways, so it's not a big deal, is it? So when you have a console application and you want to inspect the output, you don't want it to close right away. One solution is to start without debugging. And that's what we're going to be doing in this tutorial. Now you may notice that this program does all of Jack and shit, and Jack left town. So let's add a little something something. We're going to include a header file, stdio.h. And this is the standard input-output header file. It will allow us to do input and output in a standardized manner. Yes. So without further ado, let's do our first output. Put car. This is for put character. This will allow us to put a character on the display, and it receives an int as its parameter. So we're going to put a 1 on the screen. What do you think is going to happen? Make a prediction. What do you think the output will be for... Oh, what did I do? I broke it. I think I broke it, bro. Whatevs. Alright. What do you think will be the output for this program? It's a happy face. It's Mr. Happy. It's Mr. Pooh Face's little brother here. His little retarded brother. Wow. So, did you predict that was going to be a 1? The output was going to be 1? If you predicted it was going to be 1, then you are stupid. No, I'm just joking. You're okay. But it's not a 1, and it never will be a 1. So, let's try something else here. Let's put a few more characters on the screen, just for shits and giggles. We want 1, 2, 3, 4, 5, 6. So I'm going to change these numbers. Alright, I put a bunch of completely random numbers in these put car calls here. So I want you to type these numbers into your main function, and then I want you to run it. So do that now. Type these numbers in and run the program. Are you done? Okay, let's see what output we get here. I'm gonna build. Succeeded. And we get pubes! It's pubes. 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 Yeah, I totally punked you there. Now you got pubes on your computer. I tricked you into putting my pubes in your computer. And now your computer has my pubes in them. So there. Ha! But seriously, bro, is your mind totally blown by this? Are you like, what's going on? I'm confused. The problem for some people might be like, we got numbers, but then we got letters. And if that's a problem for you, then I would like to direct your attention to the first rule of programming. The first rule of programming states, let me just say this. Rule number 1. Everything is a number. Yes, everything in programming, everything in computers, in information systems is a fucking number. Oh yeah, I forgot the fucking part. Everything is a fucking number. So, if you imagine opening up a memory module in your computer and looking at it with a really small microscope, and seeing like parts of memory that's like sound, and it has like little squiggly lines because it's sound, and like other parts of memory that's image, and so it has different colors and stuff like that. That is total bullshit. Everything in your computer is a number, and all the numbers look exactly the same. So if you think you need some kind of special data type, like for example car, which we'll be coming to later, in order to display characters on the screen, well, you're fucking wrong, because everything's a fucking number, and ints are numbers, therefore ints can be characters. It all depends on how the computer interprets those numbers. And if we pass the number to a put car function, it's going to interpret it as a character. Now the question here is how do we decide what numbers represent what characters? And the answer, my friends, is ASCII. ASCII and you shall receive. Ha ha ha. Ha ha. So what is ASCII? ASCII. That's the American Standard Code for Information Interchange. Maybe. I forget. But I'm going to say that's what it is. It's a code. It's been around since like the 60s, bro. So it's old. And it determines what numbers will represent what letters on the screen. So, for example, a capital P is 80. And if you look at our first put car call, that is an 80. So there you have it. Numbers is letters, and if you put car a number of numbers, you get a number of letters, and that's like a sentence. And you can get words and you can communicate, and that's good. But the problem is I don't want to like have to call fucking put car every time I want to jam a single letter on the screen. That would be a major pain in the ass, bro. So what we're gonna do is we're gonna formulate a more gooder solution. Yeah, gooder. So let's make an int string array, and this array is gonna have 1, 2, 3, 4, 5, 6, 7 elements, and it's gonna not fucking God damn it! I hate my keyboard. I hate it because it's a Japanese keyboard and all the keys are in the wrong fucking spot. There we go. And I'm never gonna learn how to type on a Japanese keyboard. It's just never gonna happen. Not with symbols, bro. Okay. Now I'm gonna show you a little trick. Now we could make an array, and then we could try to find our backspace key. We could make an array, and then we could fill it up with our ASCII codes. So we could say string at 0, ha, I found it, equals 80, and so on and so on and so on. But I have a shortcut for you guys. This lesson is going to be about a bunch of stuff, and one of the things it's going to be about is shortcuts. We got a lot of shortcuts coming. Shortcut number 1. Here is how you initialize an array in a shortcut kind of manner. You do this: 101, 101, 115, 33, 10. Oh, by the way, before I continue, I just want to clarify one little point. Let's run this again. So pubes, exclamation mark, that's 6 characters. And here we have 1, 2, 3, 4, 5, 6, 7 characters. What's with the disconnect, bro? Well, the last character here is actually what we call the new line character. So it gives us a line break, right? If we didn't have this 10, this press any key to continue would come right after this, and it would just be like bad. So we put this 10 here, and that gives us a line break. Alright, with that said, we can delete this shit now. We have an array of integers, and those integers just happen to represent the word pubes in ASCII. So let's display that on the screen in a clever manner. For int index is equal to 0 as long as index is less than 7, index plus plus, and now we want to put car string at index and close braces. And this should do the same thing that the other thing did, only it does it with a loop. And that's good because we like loops. Because loops, what the fuck, bro? I fucked one up. Okay, that was wrong. This is supposed to be 117. Grr. $117. Oh, god damn it. On this keyboard that I'm using, the backspace key is like smaller than a normal letter key. I don't know why they couldn't give us a fucking big backspace. but it just pisses me off. Okay, so now we've got this thing and it should work. And it works. It's a loop and it works fine. So this thing here, if you couldn't tell by the name, this is a string. That's all a string is. It's just an array of numbers, except that those numbers happen to represent letters. So it's an array of numbers in some kind of encoding for characters to be displayed on a screen or transmitted somehow. Yes, that's all a string is. It's just an array. So, next thing I want to talk about. This solution of putting our strings in an array and then looping through them to display it on the screen is a good solution, but it's one of those things that we really want to put in a function, because you're going to be putting a lot of strings onto the screen, and so you're going to be having to write this loop over and over and over again. And we don't like to write the same code over and over and over again. We like to put that shit in a function. We like to refactor that shit. So let's get on it. Void. Put string something. We got some kind of thing in here, but we're not sure what yet. I'll just put ellipses. Alright, and then we got some code. Now, we have a problem. And the problem is this. Up until now, we've been able to pass, single values to a function. But how the hell do you pass an entire array to a function? Think about it for a second. I mean, if you did this as, like, say, int character, you could pass, you could do something like, let me find my backspace key. There it was. You could do something like put string and string at 0, and you could pass it the first character of the string. But what about all these other ones? You can't, no, it just doesn't work. So you can't use a normal parameter to pass a whole array to a function. It just won't fly. So how do you go about that shit? Well, if you are savvy, you might think back and remember that the last episode we learned about pointers, and you may think, well, maybe pointers have something to do with it. And you would be correct. But let's analyze this situation here. Let's say that we pass, we try to pass our array as a pointer. So we need int pointer, and I'm going to change my variable name here. I'm going to call it p character to signify that it's a pointer to character data. P character. Alright, it's a fairly common naming convention in C languages to start off your pointers with P. Now, okay, so I can pass this as a pointer to character, and then I can access that character by using the dereferencing operator. But, well, let's just see what happens here. We'll build the solution, and we get a failure. Put string cannot convert parameter 1 from int to int pointer. Right, because we're trying to pass it a int value, but what it wants is an address of an int. So we'll go in here and we'll put an ampersand in front of this string to get the address of element 0 of string. And we'll build that, and it works fine. So now if we execute this, we get press any key to continue. Yeah. Which makes sense, right? Because we're pointing to this element here, and our pointer is only pointing to one element, so how do we expect to access the whole array? Let's take a more in-depth look at the picture of what's happening here. Wait a second, and I will draw you a diagram. Alright, so basically this is what's happening in our program. We have our array of ints here, which is our string, and then we have Well, when we call putString, what the compiler does is it will put or it will allocate space on the top of the stack for the p character argument. And when we call putString, we're going to pass it the address of the first element of our string array. So we're passing that address into p character. So p character's value will be set to 0042, which is the address of the first element of our string array. So far so good. Then we call put character, and we call it with the target of p character. So the computer will first look at the address stored in p character 0042. It will retrieve the value from that address 80, and it will put that on the screen, which will cause a p to appear. And it's going to do this over and over and over again, and we're going to get a lot of p's, and it's not going to be good. We're going to get p all over our screen. It's going to be gross. But here is the trick. If I were to do something like put char star open bracket p character plus 1 close bracket semicolon p character plus 1, what do we get? Well, first thing the compiler does is it retrieves the value of p character, which is 0042. Then it adds 1 to that, so we get 0043, and then it dereferences that calculated address. So it goes to 0043, which is 117, and this line will draw a U. This is what we call pointer arithmetic, and we can add numbers or subtract numbers from our pointer, and what that will do is that will cause our pointer to be offset. So if our pointer is pointing to 42 and we add 1 to it, now we'll be talking about 0043, which is the next element in the array. And with using this pointer arithmetic, we can now access all over our array. So let's try this out for a second here. So first test, that's not what I wanted to do. I wanted to do this, and then I wanted to do this. First test, let's just try out our theory here. So we got all p's with star p character. Let's try star p character plus 1. As a side note, you have to have these brackets here. If you don't have the brackets, if you just have, for example, like this, star p character plus 1, you will get a different result. Try to think of what results you will get from this compared to from this. But anyways, we do p character plus 1, we do a little pointer arithmetic, and then we dereference the result of that arithmetic. And what we should get is we should get a bunch of u's this time. Lowercase u's, because that's the next character in the array. And I started with the wrong one. We'll start here, and yeah, we get u. Press any key to continue. So, can you imagine what we want to put here? Think about it for a second. Pause the video if you have to. Are you done? The answer is we want to put our loop variable here, index. And that way, the first time we loop through, we'll just be doing p character, which is 80. And then the next iteration of the loop will be keep p character plus 1, which is 117. Then plus 2, plus 3, plus 4, plus 5, plus whatever. And this should allow us to draw or to print out the entire string. And there you have it. Pubes, 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 pubes. So there you have it. This is called pointer arithmetic, and it is very useful. With this pointer arithmetic, we will be able to pass the first element of an array as a pointer, and then using that pointer we can access any element in the array. Now it's time for a bit of a mind fuck. So check this out. We can use this syntax here, dereferencing, and then we do some inside of brackets. We do some pointer arithmetic. But there's another easier way to write this kind of pointer arithmetic, and it's called. We do it like this. If I can find my... This means exactly the same as the code I had just before. It does the exact same stuff. Build solution. See, it succeeded, no problem. And if I start without debugging, good solution. Try it yourself if you don't believe me. Now, why is this a mindfuck? Because this is our indexing. This is our index operator. And that is what we do for arrays. That's for arrays, but yet we can use it for pointers. Is that crazy or what? So, I mean, you can type, let me just type it out again for you, side by side. You can type this, p character plus index, or you can type this, and these are exactly equivalent. So we don't really type this syntax out very much. I just wanted to show you that it's the same thing as dereferencing, only it has a little bit of pointer arithmetic added in there. But this and this is the same thing. So what this index thing is doing is it's saying add index to the address of p character and then dereference that address. So access the data at that address. Alright. Pointers and arrays. They're actually very similar. Let me show you another thing. We covered this in the last lesson, but let me ask you a question. P character, this number or this name by itself, no dereferencing, no nothing, just by itself, what does it return? What does it mean? Well, it means the address pointed to by p character. It's the actual address, not the data at that address, right? It's the address contained in the pointer. It's an address. And you know what? If you put string by itself without any index, this is also resolves to an address. But this resolves to the address which is the first element in the array. So you don't have to put address of string at 0. You can just put string by itself, and that will return the address of the first element in that array. And that's normally how you pass strings. You don't go address of string element 0. You just go string. And if I build this, success. So arrays and pointers are almost the same thing. They're almost the same thing. They're so similar it's not even funny. The only difference is that an array, you can't make it point to something else. The array name will always refer to the beginning of the array. You can't make it point somewhere else. But strings, they can point wherever the fuck they want. That's the only difference, really, between these array symbols and string symbols. Not string symbols, pointer symbols. Too many words. So, yeah, just a little bit of a mindfuck for you there. If that doesn't make sense right now, then just forget about it and it'll make sense later. Forget about it and let's move on. So, the main thing here is that we pass the address of the first element in our array, and then using that and the loop, we can access every element in the array with the pointer and the index operator. Now, let's continue to develop our idea of strings. So this function is pretty neat here. It allows us to put a string on the screen, but it has its limitations. The first limitation, well, the main limitation, is that the string has to be 7 characters long. If it's shorter than 7, we're going to run outside of the array, and that will be bad. And if it's longer than 7, we're only going to print the first 7 characters, and then we're gonna give up and go home. So, I mean, that's fine if you only have one string and it happens to be 7 characters long. But let's say you have another string, int string 2, and let's say that string is we'll say it's 4 characters long, and let's initialize it. And I'm going to show you another shortcut here, or sort of a shortcut. It's a little trick. And backslash n. I'm going to find it. There it is. There we go. All right. So, the compiler is very nice to us, and it has an option where instead of entering the character codes as actual numbers, if we put single quotes around a letter, it will convert that letter into its corresponding ASCII code. And that's very nice for us. So we don't have to type in, raw numbers. All we have to do is put letters and put these single quotes around it, and the compiler will handle the rest. Now this one here is special. This backslash is it's an escape code. So if there's a bunch of escape codes in the compiler, and what they do is they tell the compiler to do something special. In this case, backslash n will tell the compiler to insert a new line character into here, because you can't very well type a new line. Like if I were to try to put a new line in here and compile that, it'll just get an error. New line in constant. That's no good. So you can't put a new line in the middle of a constant. So what you have to do is you have to use an escape code and tell the compiler that you want this to be a new line. Or you could just put the number 10 in there, wouldn't matter. But since we're using character literals here, this is called a character literal. This is a numerical literal. This is a character literal. And since we're using character literals, we'll be consistent, and we'll also use a character literal for the new line. So, just a different way of initializing your arrays or your strings. So now we have 2 different strings, and they have different lengths. So if I were to call put string on both of them, put string 2, build solution, and start without debugging, I get pubes and I get bro, and then I get some garbage and then press any key to continue. So that garbage was the extra 3 characters after this new line here. That was undefined, right? Because it's not part of this array. So we need a way of telling putString to, hey, bro, calm down. You know, you don't have to print all that. Or, no, bro, print more because we want more letters and shit. Now, the easiest way to do that would be, let's see here, we could do int length. So what we do is we make our function so that we have to pass it the length of the string. And if we do that, as long as we know the lengths of our strings, it's no problem. We just pass 7 to this one, and we pass 4 to this one. Build, start without debugging, and now it's fine. Pubes, bro. It's all good. So we can do putString, and as long as we know the length of our string, then we can print it out, and it's good. That's one solution to the problem. Now I'm going to show you another solution. So in this case, we're going to change it up a little bit. We're going to add a parameter called pEnd. We're going to rename this one to pStart. And we're going to delete this one. So what we're going to do is we're going to pass our function a pointer to the start of the array and a pointer to the end of the array. And we're going to use a different pointer arithmetic here. Different kind of pointer access. So up until now, we've been looping a certain number of times, and we have been indexing from the base address of the array. So the pointer would point to the base address of the array, and then we would add the index to that base address to get at our current character being printed. Now we're going to do it a little different. So just sit back and watch me work my magic. So we're going to check to see if pStart is less than pEnd. And if pStart is less than pEnd, pStart ++. All right. And now we're just going to do putChar at star pStart. All right. Now you might be wondering what the hell is going on here. So what we're getting is we're getting a pointer to the beginning of the array. Let me just show you on the diagram here. Oh, I gotta change some stuff. Wait a sec. Alright, so here's how our memory is laid out as we call the function. We have pStart and pEnd. Now pStart, we're going to call the function such that pStart, as usual, points to the first element in our array. But pEnd will point to the memory location that comes exactly after our array. So it'll point to the memory location right after the end of our array, which in this case would be 0049. Now why are we doing that? Well, what'll happen is we'll keep looping through. Let me just show you. We'll keep looping through here. We'll be comparing pStart to pEnd, and as long as pStart is less than pEnd, we putChar the target of pStart, and then we increment pStart. So first time we call putChar pStart, we'll put a P on the screen. Then we increment pStart. So this one's now 2243. is 2243 less than, wait, 0043. Is 0043 less than 0049? Well, yes, it is. So then we put a U, we increment, now it's 4. Is 4 less than 9? Yes. Then we put a B, increment, 5. Is 5 less than 9? Yes. E, 6. Is 6 less than 9? Yes. S, 7. Is 7 less than 9? Yes. Exclamation mark. 8. Is 8 less than 9? Yes. Carriage return, or new line. 9. Is 49 less than 49? No. So we end the loop. And the loop ends. So we can compare, this is new, we can compare pointers to each other, just like any other number. And we can increment a pointer so we can change the location that it's pointing to permanently. Right? In the other one, we were just indexing from the base pointer, but the actual value of the pointer wasn't changing. But we can also increment the pointer, and we can let me think here. We can make that pointer roll on down these values one at a time until it gets past the end of the array. So yeah, that's how that works. And if we were to call this function, we'd have to call it like this. We'd call it with string, that's the address of the first element, and then we'd have to do address of string at 7, which is the memory address that's right after the end of the array. It would be over here somewhere. And that's just so that it works out in the loop. String 2 at 4. And if we do this, success. And again, no problem. Works out fine. So this is just another way of skinning that cat. And it has an advantage over the other one in that incrementing and dereferencing is cheaper than using a index operator. It's actually faster this way. It's slightly faster. Most of the time it doesn't matter, but in certain performance critical sections of code, this small optimization can actually speed you up. So this is just another way of accessing the array with the pointer. One way is you use the base address of the array and you use the length of the array. The other way is you have two pointers, one to the beginning of the array and one to the end of the array, or the location right after the end of the array. So now that I've shown you two different ways of accessing the array from a function, let me show you another way. And this way is interesting in that this is the way that we will actually use in programs. So in this way, we only need one argument. We can call the function just with the pointer to the beginning of the array. We don't need the length of the array. We don't need to know the address of the end of the array. All we need to know is the address of the beginning, and we can draw the array or put it up on the screen. And we'll also be using the, again, incrementing the pointer here. But we'll not be using comparing two pointers because we don't have two pointers. We only have one pointer. What we will be doing is we will be checking the value at the current target address. So p start, wait, as long as p start is not, fuck off, not equal to, as long as star p start is not equal to Here's another escape character. And this is the null character. It's actually 0, so I could type a 0 in here. Or I could type a null character. Doesn't matter. So as long as the value pointed to by pstart is not 0, increment pstart and put it on the screen. Or put it on the screen and then check if it's not equal to 0. And if it's not, then increment it. Or something like that. First check, then put, then increment. Yeah, that's the order. So what this is going to do is this is going to keep looping and keep incrementing. We'll call this one pcar, because it's not really start and end anymore, is it? Yeah, I know I'm picky about my variable names, but the variable names should really reflect what's happening in the program. Otherwise, I don't know. Otherwise, I hate you and you should die. So that's how that works. And what happens is it keeps incrementing pcar until it comes to a 0, and then it stops. So what we need to do now is we need to put a 0 at the end of our strings. And that 0, or that null character, this tells the function that this is the end of the string, so give it up and go home, because if you keep going, you're going to fuck something up. That's what that does. And what was I going to say? I don't know. But we need to get rid of this. There we go. So this adds a little overhead to our strings. Our strings now have to be 1 character larger in order to accommodate the null at the end of the string. But it makes our function calls easier. All right, here, too many initializers. So if you say the string is 7, but then you put 8 elements in the initializer, it'll say, what? Go home. Ravers, go home. And so you have to put it 6. But here's a little trick. If you have an initializer, you don't have to put the number in here at all. Just leave it blank. And if you leave it blank, what will happen is it'll make the array the size of the initializer. So it'll automatically resize your array depending on how many things you put in the initializer. Makes life easier. And we have success. And now if we call these the put string function, and we get the expected result. So happy days. And this, my friends, is actually how strings are represented in the C standard library and in most C programming. This is what we call a null terminated string. That's an actual term. Null terminated string. And they're also known colloquially as C strings, because this is the way you use strings when you're programming in C. It's a C string. It's just an array of numbers with a 0 at the end. Alright. Alright, I just took a little break there and had a little drink of water. If you need a break, you should feel free to take one. I was thinking about stopping the video here and continuing in the next lesson, but I think I will soldier on. But yeah, if you feel overwhelmed, take a little break, come back later, maybe even review the first part, and then continue on. We are going to take a slight little detour here. I want to introduce a simple, not so simple topic that happens to be pertinent to what we're doing right now. So I'm going to talk about that, and then I'm going to blow your mind again, and then we're going to learn a couple new functions, and then I will give you homework. Okay, let's continue on. It's now 2:20 a.m. here, and I've got tennis tomorrow morning, but I am going to make more tutorial. See what I do for you guys. See what I do. Alright. Now, so let me just recall to mind exactly what we did here. Alright, so we made our putString function, and it was good. And we rested on the 7th day. And now we are going to make the putString function even better. Even fucking better, people. Now, here's the thing. Let's say you were, real drunk when you wrote the putString function. And you did something crazy. Like, you did putCar. Well, first, I'm going to just do something here. I'm going to write a line of... I'm just going to make the program, and it's going to call putString twice on the same string, the first string. So, what do you think that this will do? What do you think this code will do when we run it? Right, it just outputs our pub string twice. Fair enough. Now, let's say that you got drunk when you were programming the putString function, and after putCar, pcar, you wrote a line here. Pcar is equal to 1. For some reason I don't know, you were on drugs, whatever. Now this is a problem, especially, let's say you're only drawing, or you're only outputting putString once here. So you run this program, and you test it, and you say, well, it works fine. I called the putString, it put the string on the screen, everything's good. But look at what this program is actually doing. It'll loop through every character in the array until it hits the null character. And what it's doing is it's putting that character on the screen, sure, but then it's setting that character to 1. So it's actually overwriting your whole frigging string except for the null character, because when it hits the null character it exits the loop. So it leaves the null character, but it overwrites all of the actual display characters in your string. And that's bad. That is not something that a putString function should be doing. It should not be messing around with the string it's putting on the screen. It should just read it and display it. End of story. And of course, if we try to put the string a second time after it's been mangled, you will see that putString has took a big steaming dump all over our string and replaced it with happy faces. It's just a big, like, fuck you, man. I just fucked up your string. So, this is not good. But there is a way we can avoid, stuff like this, and it does not mean we have to abstain from alcohol or narcotics. If we have a function like putString, and that function is not supposed to change the variables that it receives, what we can do is we can declare the argument as a constant int pointer. Constant int pointer to pcar. And what this does is this puts a restriction on this argument here. And that restriction says that, okay, we've got a pointer to this integer, or this array of integers, but we may not alter the array of integers. We can't change anything. We can read it, but we are not allowed to write. And if we put this restriction on our argument here, and we try to compile, we get an error, failure. Error, pcar, you cannot assign to a variable that is const. So this will tell us when we are in our drunk state of, oh, I'm gonna code some we're all drunk and trying to code a game. This will allow the compiler to say, hey, what are you doing, fuckhead? You're not supposed to change that. So, if we have a function and we know that it's not going to change any of these variables, we should declare them as constant pointers. Constant int pointer to pcar. It's something we should do. And if we do it like this, we can avoid problems. There's other reasons why we should declare them as constant pointers, but I'm not going to get into it. The main thing here is doing it like this will save us headaches and will prevent us from doing stupid things. And that is part of being a good programmer. Actually placing restrictions on your own code to prevent you from doing stupid things later on. And we'll get into that a lot more when we hit C++. We're still in C, by the way. But for now, just know that you can do this for your functions, and you should do it. This is called const correctness, and you can look that shit up because you can Google that shit. That's real shit. And yeah, so that's what the constant does in this case. It makes it so we cannot access we cannot mutate these or change their values. Alright, so that's the first thing I wanted to talk about. Now the second thing I wanted to talk about is I wanted to blow your mind, bro. So here's our diagram of here's our diagram of the memory, and as you can see here we have wait a second. Alright, I updated our diagram here to reflect what we were doing in our program. So now we have an extra element in our string array, which is the null terminator, or the 0. And now our pointer is constant int pointer to pcar, and it's still pointing to the beginning of the array, which is what it will point to at the very start of the program call. Although as the program progresses, or as the function proceeds, the pointer will be incremented and it will go down, down, down. But anyways, so this is the concept that I've been selling to you guys up until now. But there's a little bit of a there's been some stuff I haven't been telling you. I've been kind of shielding you from the truth here, and it's time for the big reveal. So let's keep this diagram in mind as we debug this program. So I'm going to set a breakpoint here to the beginning of our function call, and I'm going to start debugging. I'm going to start debugging the program. So first thing we notice is that pcar's value, which is the address that it points to, is hexadecimal 0041 FB04. So that number is the base address of our string. This is where our string actually is in memory. So B004. Now, so I'll step and I'll put a character onto my display, and if I look at my display now, it has a P. So so far so good, right? Now I'm going to step here. Wait. Autos, locals, pcar. So far it's pointing to 0041 FB04. Now we'll step. And we'll step again. Now it's pointing to FB08. FB08. Well, what the fuck, bro? We just jumped 4 memory addresses. So if we jumped 4 memory addresses, first of all, we incremented it. We did a plus here, so we should only go up by 1. But if we indeed did go up by 4, then according to this, our next character should be, let's see, we go up 4, we go 1, 2, 3, 4. Our next character should be this character, which is probably the S, right? So we should expect to see an S come pooped out on the screen. So let's look at it. But it's a U. What could it mean? And again, if we move and we step again, now it's 0C, which is 12 in hexadecimal. So we've moved up by 4 again. So what is going on, bro? Why are we moving up by 4? Can you, maybe some of you know, maybe some of you don't know, but I'm going to tell you. The reason why we're moving up by 4 every time is that a single int, here's the big reveal, a single int actually takes up 4 memory addresses. It doesn't take up a single address. It takes 4 memory addresses to store one int. So if this were to be accurate, an accurate diagram here, we couldn't hold this in here. Let me just erase some shizzle. If this were to be accurate, our first integer, which was I think 80, would occupy all of this. This would all be string at 0. And string at 1, which was, fuck, I don't know, like 117? No, fuck, that's the wrong spot. 117. That would be all in here. Let me illustrate with you. Let me illustrate you some mathematician stuff. There, 80. 117. It's like this. It takes up 4 memory slots to hold a single int. One memory slot here in how do you say, how to explain it? All of us are right now using x86 computers like Pentium or Core i something, Core i7 or something like that. I don't know what kind of CPU you're using, but whatever CPU you are using, I can guarantee that you're using an x86. Unless you're like watching this on a Mac, and then I'm like, why the fuck are you watching this on a Mac? You can't run this program on a Mac. Well, I mean, you might be watching this on your iPhone or something, but okay, if you are running the framework, you're running the framework on an x86, right? And x86s, they address memories. The smallest unit of memory they can address is 8 bits, which equals 1 byte. All right? 8 bits. It's a memory unit size thing. So they access memory in the smallest at 1 byte at a time. So every one of these addresses here is 1 byte. Now an int takes 4 bytes, which is, if you can do your math, 32 bits. And that enables an int to store, wait, let me look it up. Alright, I got it here. This enables an int, here's int, 32 bits, common integral data types. 32 bits. This enables an int to store from -2 billion to +2 billion. So that's the amount of, that's the range of values that we can store in an int, which is 32 bits, or 4 bytes. Alright? And when we increment a pointer, for example, p car, the compiler is smart enough to know that we're accessing ints. So the next int is going to be 4 bytes away. So it increments it by 4, not by 1, because it knows that we want to get at the next int. If we were to only to increment by 1, we would be accessing the last 3 bytes of this int and the first byte of that int, like part of one and most of the other, and that would just give us a messed up number that doesn't make any sense. So the compiler is smart enough that if we have a, for example, an int pointer to pcar, it knows that when we increment the pcar, we're going to go up by 4, because ints, the size of an int is 4. Alright? So, the mindfuck here for you guys is that ints, their size isn't 1, they don't take up 1 memory address, they take up 4 spots, or 4 bytes in memory. And that is why our pointer is going up in increments of 4 every time we increment it. Yeah, so that is what I wanted to tell you guys. Ints take up a bunch of space. Now, there's other things I could talk about in terms of memory access and the size of variables and shit like that, but I don't want to get into too much detail right now. I just wanted to let you guys know that different variables take up different amounts of space in memory. Now, just before I mosey on down to the next topic, so far we've done int, float, bool. We've also done enums, which are user-defined, and we've done structs, which are user-defined. Now an int takes up 4 bytes. Float takes up 4. Bool takes up 1 byte. Enum takes up 4. It's basically the same as an int. And structs, they take up, it depends on what you have in the struct, right? If you have 2 ints in your struct, it's going to take up 8 bytes total, right? 4 times 2, and so on. So the struct depends on how much shit you got in the struct and how big that shit is. But I don't think we've covered any other real data types besides these ones. Maybe I'm wrong. I can't remember. Anyways, what was I talking about? Oh yeah, ints are kind of big, but not that big. So think about it. Now here's the deal. Here's why I sort of wanted to talk about that. If you look at an ASCII table, the values that you can have for your characters, they range from 0 to 127. That's the range of values that you get for your characters. However, an int can store negative 2 billion to positive 2 billion. Now, I don't know about you, but to me that sounds like a bit of overkill. Why do we need that much range when we could easily fit our characters inside of a much smaller range? So in comes a new data type. And that data type is the car. I call this a car. It's probably a stupid way of saying it. I don't know how other programmers say it because I don't talk to other programmers. But I call it a car. You can call it a char, or you can call it a char, or you can call it a character if you want. I'm calling it a car. And if you don't like that, then you can go and blow me. So this is a car. Now, if we declare this thing as a car, and we declare this thing as a car, how will that change our program? Well, it compiles, and it runs fine. No problems here. Put that one on string 2. No, there's no string 3. That doesn't exist, bro. String 2. And there you go. Pubes, bro. So everything runs exactly as it did before, except here's the rub. A car only takes up 1 memory slot instead of the 4 that you need for an int. So it's 4 times smaller, and you get the same result with only 1/4 the fat. It's very slimming. It's a very slimming data type. And the difference between a car and an int, you might think, oh, character, that must mean it's for characters. But no, it's for numbers, right? Ints are for numbers. Everything is a fucking number. Don't forget rule number 1. So it's not, oh, it's a char, so we must use this only for characters. You can use cars for anything you want. The only difference here is, if I get back to my Wikipedia page, a byte or an octet, which is what a car is. Look, C++, car, gives us values from -128 to 127. Whereas if we go down here, where's our int? Int. Here we go. Int gives us negative 2 billion to positive 2 billion. So if the values you're trying to represent are never going to be outside of negative 128 to positive 127, you can use a char to represent those values. And characters, they only go from negative 128 to 127. So we can use a char to represent our characters. Int is overkill for strings, so we don't use it for strings. We use chars. Yeah. So that was the other thing I wanted to tell you. So the reason I started off with ints was just to basically hammer home the idea that character data, text data, is no different than any other kind of number. And we can use ints to represent it if we want. The only reason we use chars to represent characters is because ints are overkill. We could if we wanted to, but we don't. Because chars do the job fine and they're 4 times smaller. Alright, so that's characters for you. And you can use them, you can use the char data type wherever you don't need the powerhouse range of an int. Okay, now, next thing we're going to talk about. So a little bit more and we'll be finished this lesson, and I will give you copious amounts of homework. Alright, so let's get on with it here. So we've got some string output, and it's working pretty nice for us now. It's a very nice string output function. For me to poop on. No, it's good stuff. But the other part of console stuff is console input, basically keyboard input. It's all fine and well to be able to spit stuff out at the user, but you also gotta take some too. And the way you do that is with the what do you call it? You know, the thing. You know what I'm talking about. No, you don't? Okay, well, I'll show you. First, I'm going to comment this out because we're not going to use it right now. And I'm going to create a buffer here. We'll give it 128 characters in our buffer. Alright. Int size is equal to 0. And we're going to get some input from the user here. So we'll write a loop here for int index is equal to 0 as long as index is less than 128. We don't want to go outside of the boundaries of our array or our string or buffer. And char c is equal to 0. And c is not equal to this one. Backslash, I said backslash, didn't I? Backslash n, new line. Index plus plus. So what is all this garbage here? Alright. C is equal to get char. So this will, when we call get char, the program will stop here and it will wait for the user to press a key. And when the user presses a key on the keyboard, then this get char function will return the value of that character, and it'll be moved into C. So this function is a blocking function. When we call it, the execution will halt here until the user presses a key, and then it will continue. So we can get characters, we can move them into C, and how do I want to do this? If C is not equal to, again, new line. If the user presses enter, we'll get a new line character. So if C is not equal to new line, then buffer at index is equal to C. Then we move the value of that character into the position in the buffer indicated by the index. Capiche? So what this program will do is it'll continuously get characters from the keyboard and place them one after another in the buffer until the user presses enter, or until the index becomes greater than 127 or reaches 128, in which case we will have exceeded the buffer, so then we want to exit. Actually, we want the maximum to be the buffer minus 1, because the very last character in the buffer has to be the null character, because this is going to be a string, and strings have to have a null at the end. So we have to remember we need one slot at the very end for our null character. So at the most, we can store 127 characters plus one null character, the terminator. The terminator. Yeah. So we loop through our mother trucker here, shoving in characters into our buffer, and after we reach when we're finished entering characters in the buffer, we add poop. I'm gonna have to declare index outside of this loop here, because I want to be able to remember the very last index of where we were to put a character. So buffer at index is equal to what? Is equal to the null character. So at the very end of our buffer, wherever that may be, we want to put or at the end of our character data in our buffer, we want to put a null character to show that that's the end of the string in the buffer. Right. So this code here will read in a string from the keyboard and store it in the buffer. And at the end of the stored text, it will put a null character to terminate that. And then we can do something like this. We can, well, let's, all right. There was something I wanted to show you guys and I forgot. Okay, so far I've shown you guys how to declare a string, an array for a string, by using an array initializer with numbers, and using an array initializer with character literals. Well, there's another easier way to do a string. We can go char string equal to, and this time we use double quotations, and we can type in a whole bunch of text. So you typed the following text, blah, and there. So how is this different than this? Well, besides the fact that their content is different, initializing an array with double quotations, how is that different than initializing with curly brackets? The difference is that if you initialize an array like this, what C will do is it will add a null terminator to the end of this string to make it into a C string. So this array, the size of this array is 31. You can see right here. Car string 31. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. 30 characters in here, plus the null terminator that is added at the end because we use double quotations. So double quotations lets you put a whole bunch of characters one after another. You don't have to type quote, character, quote, comma, quote, character, quote, comma. You can string them all together. And it also puts a null terminator at the end for us, so we don't have to worry about adding the null terminator. And it is the normal way to declare a string. This is called a string literal. Character literal, integer literal. Integer literal, character literal, string literal. That's what it is. And that is how you do it. So we'll create this string here. We'll call it string. And after we read in some text from the keyboard and store it in the buffer, we'll do put string string and put string buffer. And just to be safe, put string we can also do this. New line. We can pass this thing a string literal by itself. We don't have to store it in an array first. We can pass it just like this. And this string literal actually resolves to an address. It's the address of the first character in the string. So, build. Success. Uninitialized local variable index used. We actually initialized two different indexes here. We initialized an index outside of the loop, and then we initialized another variable with the exact same name inside the loop, which you can do. And if you do that, the index inside the loop actually covers up the index outside the loop. And when you exit the loop, then the index outside the loop gets used. So if I would have left it like that, I would have gotten a really fucked up error, and it would have been bad. Thank you, Mr. Compiler, for seeing that. Alright. So let's start without debugging. And let's type in a word here. We'll type in the word, foobar. Foobar. You typed the following text. Foobar gabba. Okay, I think I fucked something up here. Why is it doing that? Buffer at index is equal to... Maybe it should be buffer at index -1? Why would it be index -1? Now I'm confused. Enter in here, put a character at 0. We get the character. Right. So our index is pointing at... Well, that doesn't make sense. Now I'm confused. I'm probably doing something really stupid here. Sometimes things just don't make sense to me. Actually, most times things don't make sense to me. You typed some text. What the fuck, bro? Question mark, exclamation mark. You typed the following text. What the fuck, bro? Question mark, exclamation mark, crazy thing. Why? I'm thinking it's because I think maybe when you type the enter key, you get some crazy character coming out, but I'm not sure what it is. So I'm gonna debug this mother. We'll see some debugging in action here. Okay, so we stop here, we step into it, and now it wants the key being pressed. So I'll put a B in there. What? Interesting. So I just learned something about the behavior of this getChar function. It doesn't return after you press a single character. So after you press the B, it doesn't return and then go B and then come back and wait for another character. What'll happen is it'll sit here, and we can keep pressing characters and character after character after character after character, and it will still sit here. It won't leave this function. It won't return anything. And when we press enter, then it will return and it will put a value into C, and that value will be the first character, which is B. Alright? We put a B here. And then we can loop through here, come back, and now it will return the second character, which is an F. See, it returned an F. So what happens is when we type into the console, it's actually storing these characters in a buffer, and it will keep storing them until we press enter, and then it will give them to the then the function will keep returning and stuff out of the buffer until the buffer is empty. And when the buffer is empty, then it will block here, and we can type more stuff in. So that's interesting. That is very interesting information. But it still doesn't tell me why. Let me just check this out here. It doesn't tell me why I was getting that crazy character at the end of my buffer, or at the end of my string in my buffer. So BFDSAR. BFDSAR. Now here's the moment of truth. This is where our enter key should be. And it's a 10. That's good. So now we stick a 10 into this position here in the buffer, right? Oh no, because we skip it. We skip it, so we don't put a 10 in there. And then we increment, because we end here, then we increment, and then we check to see whether it's equal to... so our pointer is incremented, but we never put anything inside of that in the space after R. We skipped it because C was equal to new line, so we skipped it. And it just ends up being whatever happened to be in that space of memory, which is garbage. And so we get one garbage character. And then, alright, so at the end here, I was thinking that we would just exit, but of course we don't just exit. First, we increment our index, and then we check, and then we exit. So In that case, how do I solve this problem? I guess the easiest way would just be index minus 1, because we know that the index will always be... but in the case where we hit the end of the buffer, then index will be correct. There's probably a simple solution here, but I'm not seeing it. So what I'm going to do is I'm going to make a kind of dirty fix here. So if c is not equal to n, then we buffer, else index minus minus. So when they hit enter, we'll decrement the index, and that will counteract the final increment, and we'll end up with the correct index to put our null character at. This is a quick and dirty solution, and it's kind of nasty. It makes the code difficult to read for someone who's not thinking the same way you're thinking. So in this case, I would normally put a comment in here saying I'm doing this because blah blah blah, and I know it's bad, but I can't think of a better way to do it. It's 3 a.m. and I'm tired. Okay, so that's that. Well, we learned a little bit about how the console input actually works, and we also fixed a little problem here. And now if I run the program, now we should get all better now, winky face, exclamation mark. Ba, ba, ba. You typed the following text, all better now, winky face. Good. So that is how you can do text input. You need a buffer that will accept the characters. And yeah, size is equal to 0. Yeah, I never did use that size variable, did I? That was stupid. I think that's what I was going to use index for, but I just used index. Okay, anyways, that's how you would read input from the console using get car. And now it is homework time. I know you guys love homework. Some of you guys actually were complaining that I wasn't making many homework assignments of late, but I don't know, just couldn't think of anything that was really pertinent. So I've got homework for you now, bro. If you choose to accept it, and if you don't, then you can go fuck yourself. I don't really care, but here it is, take it or leave it, homework. Let's get rid of this crap. No, I said get rid of it, not copy it, you dickface. There. Homework. So, I got a bunch of assignments. First assignment for you is just the code that we just made. I want you to factor it out into a function. The function will be void get string, and it will be car pointer to buff. So you want to write a function with this signature, and it will do the stuff that I just showed you. It'll get a string from the keyboard, and it will store it in a buffer. Should be buff and int max length, right? Because you need to know how big the buffer is. Otherwise, if the person just keeps typing forever, they'll just run outside the buffer, and then they'll start running into other memory, and your program will crash. So you need the caller to pass you a buffer to accept the characters, and the caller also needs to inform this function how big the buffer is. So turn that into a function. That is mission number 1. It's very easy. Mission number 2 is write a program to, what'll happen is you'll input a string. So input string from keyboard, and the output is string reversed. So you get a string that's input and the output is a string reversed. And ideally you should write a function that can reverse a string, either by reversing the string inside of its array or by generating the reversed in some new array. So you can do it any way you want, but the basic idea is that the user will input a string and then the output will say something like your string reversed is blah blah blah. Like you might get a message saying input your name, and then you input your name, and then there'll be another message saying your name reversed is, and whatever it is when it's backwards, right? So basically, yeah, you need to take a string and make it backwards. That is the real homework. This is simple. Simple. Normal. Now here's the hard homework. Hard. I want you to make a program, and in that program there will be a prompt. The prompt will ask how many dice to roll, comma, and then the user will input a number, like let's say 12, and then the output will be 12 random dice rolls. So the output might be like 4, 3, 1, 1, 6, 1, 5, 4, 2, 2. How many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, the user input 10. Ha ha ha. There. So the output will be like this, and there might be total value blah blah blah, and it'll sum this up. I'm not going to add them all up. It'll say it's 20. And then, you know, press any key, blah 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 blah. Okay? So this is the program that I want you to write. Now to make this program, you're going to need to make two functions. There are functions that will do this stuff for you, but I want you to write the functions yourself from scratch. And the two functions that you have to write are string to int, and it'll return an integer, and it'll take a constant car pointer. And what it'll do is you'll pass it a string, and it will convert that string into an integer. So for example, if you pass it a string, the string 112, it'll convert that to 112 in an integer. Or if you pass it a string, for example, b, it'll convert that to 0 or maybe negative, or I don't know what it'll convert it to, but I mean, because b obviously isn't a number, you can't convert it to a real number, so you'd have to convert it to some arbitrary thing. I'd just use 0 or something. But if it's passed a string, and that string is all numerical digits, it should convert those digits into a number. So if you pass it 112, if you pass it a number like, for example, 42x, it should convert that to 42. Once it hits a non-numerical digit, it should just, or a non-numerical character, it should just give up and say that the number is 42. So string to int, that's one. The other one you'll need is void int to string, and this one you have to pass it a int number, and you'll have to pass it a car pointer to buffer, and you'll have to pass it int bufflen. And what this one will do is you pass it a number, like let's say you pass it the number 149, and it will take that number and it will put it into the buffer 1 as 149, 3 characters, right? 149 into the buffer. And bufflen is so that if you put, so let's say your buffer is only 6 characters long, and you try to convert 1494156 into a string, that will exceed the buffer. So you have to add a buffer length so that it doesn't try to write a huge long string into the buffer. All right. So you need 2 functions, int to string and string to int. And if you can make those functions, then you can make the dice rolling application. And I mean, if you really want to, you can even like make a dice game out of this, like dice 1000 or something like that, or 10,000. But I wouldn't do that. But this is the hard homework. Obviously, the hard part is writing the conversion functions. This is normal hard, not so hard. This is simple. This is trivial. It's just basically doing what I did for put string, only doing it for get string. All right. So here is your homework, and I'm going to go over this homework. This will be the beginning of the next tutorial. So don't worry, you'll get the solution, but I encourage you to try at least the simple and normal homework. The hard, well, if you're feeling spunky, you can try it. You'll have to think a lot more. You can do it with all the stuff I've taught you. You don't need any special stuff you haven't seen before, but you might have to think a little bit. And I know how some of you just hate it when that happens, so yeah. So that's the homework, and that is the introduction to strings, and when we return, we will have Revenge of the Strings.